Okay, so I noticed my last video was 15 minutes. That's much longer than 10 minutes like I thought, so now we're going to have to go a little bit quicker. So we'll go 8 through 8 or 10.5, or try to go through as much as we can. And again, I'm going to try to keep this to 10 minutes, so I'm going to go even a little bit faster, hopefully. And you can pause or whatever you need to do throughout the video, but it says state the asymptote of the function x, or f of x, I missed the f here, so f of x equals 1/2 x plus 4. So this is a half-life, so this is a decay, so it's going to look something like this, right? And the asymptote, since it says plus 4, remember outside, right? Outside is the y, so the up and down. So now if I drew my graph, the normal graph would look something like this, right? Where it's almost hitting 0. But if I'm going to draw my graph, I'm just going to redraw it like this, right? And 1, 2, 3, 4. And I know I'm not perfect there. But now you can kind of see where your asymptote is. Your asymptote is that plus 4. So your asymptote is actually y equals 4, because it will never go under 4. And that should make sense, because whatever number this comes out to be, this 1/2 raised to, whatever number that comes out to be, if you add 4 to it, it can't go below 4, right? Especially none of these can be negative numbers. Can't be a negative number. Can't take 1/2 and raise it to a number and get a negative number. You can't even raise it if you raise it to a negative number. So if this was 1/2 raised to the -8th, you're still not going to get a negative number, right? So if you raise it to a huge number, 8,000, right, you're not going to get a negative number. So therefore, your asymptote will be y equals 4, because you will never reach 4. Because you'll never go lower than 4, I should say. Okay? Now it says state the x and y intercepts of this. Okay, so now what I'm going to do is I'm going to graph this, and that should help me kind of estimate where my x and y intercepts are. So I'm going to go ahead and flip screens now and graph this. So I'm going to go to my calculate 84. I'm just going to remember that it's 2 raised to the x power minus 5. So if I go to my calculate 84, once I find it, oh boy, I'll just do it in Desmos then. So it was, and let me make sure I remember this. So 2 raised to the x minus 5. So 2 raised to the x minus 5. So we have y equals 2 raised to the x power to the x power minus 5. So it should look something like this. I'm going to go ahead and zoom out, and you'll see what happens here. I'm going to zoom in just a little bit so we can, maybe I'm going to try to zoom in. There you go. Zoom in just a little bit so we can kind of see where it kind of flattens out. It doesn't necessarily go flat, but it kind of flattens out at this -5. So if I kept zooming in, so I'm going to go ahead and zoom in where it looks like it hits 5. It looks like it hits 5 right there, or yep, right here. You'll notice that it doesn't, right? It says -5. Comma -4.96. If I keep dragging this, I'm actually never gonna hit 5. See, okay, I guess okay, so it shows that I hit 5 here, but if I zoom in, it actually is not. It's the only reason why it's showing 5 is because it can't go any further than -4.9999. So, but if I zoom in here as far as I possibly can, I'm just gonna keep zooming and zooming and zooming and zooming. You'll actually start seeing the gap. See how the gap just kind of formed there? Right, so now this point right here is -4.99, and I can keep scrolling, right, and see. And then again, if I kept scrolling and kept zooming in, I know I'm zooming out right now, but if I kept zooming in, you would just keep getting closer and closer to that -5, and you'll see that it never actually hits that -5. So that's going to be where our asymptote is, right? And then if you notice here, you can keep zooming out, and again, I know I'm in Desmos, but you can keep zooming out, but you'll actually never hit an asymptote, a vertical asymptote. It's just going to keep going to the right. So so your horizontal asymptote, right, is -5. Your vertical asymptote doesn't exist. There is no vertical asymptote. So now let's go back to the question that we had here. I'm sorry, we were looking for x and y intercepts. So if we look back here, we can actually click and find out where those x and y intercepts are. I can notice right here there's an x and y intercept. Let me get that. 0 comma negative 4 is the x-intercept, and our y-intercept is 2.322 comma 0. So that's kind of nice. Pretty easy for us right there. So I'm going to go ahead and write those in for our x and y intercepts, if I can remember them, right? So our x-intercept was 0 comma negative 4, and I think I just wrote the y-intercept, didn't I? Yep. Oh, that's okay. So y-intercept is 0 comma 4, or negative 4, and our x-intercept is that 2 point, and I'm going to go back just to get a pretty precise answer here, 2.322 comma 0. Okay, so that's pretty easy for the x and y intercepts. So now if we're looking at identifying the characteristics of the graph, this is an exponential graph, so you'll see the growth, so it should be something like this. So it should look something like this, right? And if I was to write should look something like that, right? So it's an exponential growth. What is the domain and range? Okay, so the domain should be relatively easy because that's all the x values, so that's negative infinity to positive infinity, because you can literally plug in any x value you want there, right? If you want to know the range, that is all the y values. So what y values will you get? Well, if you can see, the asymptote is actually at y equals 0, so I'm actually going to write that in here. So we can see that this will never hit 0. I know with my graph it kind of looks like it does hit 0, but this will never hit 0. Therefore, your range will be 0 to infinity, because the lowest it can go is from 0. The highest it will go, like the y values, will be positive infinity. So now let's look at some intercepts. Well, there is no x-intercepts because it's not hitting 0, right? So we can just kind of x out the x-intercepts. The y-intercept is when x is 0, okay? So now that's might be like, oh, should I get the graph out? Should I get the calculator out? Well, maybe, but remember, when we do the y-intercept, right, you're just plugging in 0 for x. So I'm just going to plug in 0 here. Well, what happens when you raise something to a 0 power? 4 raised to the 0 power is 1, so your y-intercept is just going to be 0 comma 1. So we didn't even need a calculator for that, right? Just plug in 0 for x, boom. Now we're going to do end behavior. So end behavior looks at these arrows here, right? So now we're going to say, as x approaches negative infinity, so as we go to the left, our y value, our f of x, approaches 0, because it's approaching that lowest limit, right? The lowest it can go, y value, or vertically the lowest it will go, is 0. So, and we say approaches 0 because it does not ever hit 0. It just approaches 0, because that's where our asymptote is. Now I'm going to use purple again. Or no, actually I don't like that idea. I'm going to use black, kind of close to purple, right? And I'm going to go ahead and copy this arrow right here, right? So now we're going to say, as x goes to infinity. Now, please notice I say as x goes to infinity. So not as it goes up, but as it goes to the right, right? The x value goes to infinity. The f of x value is what goes up, right? So that's what f of x value is going towards infinity, because it's just going to keep going up forever. So it goes to the right forever, and it goes up forever. Now this is where it gets interesting. It says the interval of increase or decrease. Well, I hope you're looking at this and saying, okay, there is no decrease. Okay, so that's good. It's not decreasing. It's always increasing. Because when you look at interval of increase or decrease, you always look left to right. So just like you're reading a book, you're reading this from the left to the right, it's always increasing. So if it's always increasing, then the entire domain is the interval of increase. So I can literally just rewrite the domain. So from negative infinity to infinity is where it is increasing. The only thing that you want to put here is that it actually is increasing. Make sure you have enough room. So I hope that kind of helps, and I know I hit the 10 mark already. 10-minute marks go a little bit quicker than I thought they would, but I hope that kind of helps. Please feel free to use graphs. Feel free to use the calculator at this time. Stop the video, try the next one, do that. The next video will be on transformations and logarithms, so I hope we're all ready for that.